On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present.